Okay, here we go for part 2 there, folks. Example 2. These are example 2 and 3 here I like to call the Jeopardy questions. They're kind of backwards. Instead of giving us the function in this form, and have us do the graph or have us pull out the little bits and pieces of information, it's the other way. We're given the little bits and pieces of information. We have to write the function. So really, all we're doing then is we're grabbing this and having to fill in the blanks, right? That's it. That's what we need to do. So let's figure this out. Once we have these 4 things, we'll be done. Period of 2 pi over 3. Now, remember, the period is 2 pi over 3. We want the b value to be in the equation itself, right? Well, what's the b value here? Well, we know the period in general is 2 pi over little b. Well, that one's pretty easy to see, right? The b is 3. This little b is 3. And this is one of the traditional trig graphs that we're used to that have pi's along the bottom. It's going to start repeating itself after 2 pi over 3. Little b is 3. It'll be, at times, this won't be as easy, but we can set up this little equation. This is the equation for the period in general, and then the period's given to you, and then you can cross multiply and calculate b if you need to. Dandy. Amplitude is 4. Well, that's pretty straightforward, right? There you go. Amplitude is 4. Phase shift is 0. Well, that means d is 0. The axis is -2. So that means it's been moved down to -2. Done, right? All I have to do is fill it in. And it asks me for a cosine function. Notice here, is this the only possibility for this graph as I fill it in? Are there other equations that are possible? Well, a little bit. Perhaps we could have had a minus on there. If I have a minus on the front, I think all of these things still make sense. If I start thinking, well, a shift left or right, well, that wouldn't be a phase shift of 0 anymore, would it? So really, I can't have a phase shift of anything in here. But maybe I could have one that starts at its minimum first. So done. Done and done. But this is kind of a setup example for the next ones. And I don't think I'm going to do all of these. And on these ones, basically we're going to write the equation of one or the other, and I don't care which one. In fact, I would encourage you to be smart about this and pick the one that makes sense. And I'll talk about what we mean there in a second. And I don't think I'm going to do all of them. Maybe what I'll do is I'll talk about 2 of them and then let you try them and then write the answers on at the end of the video. Right. So here are the 2 equations in general. There are sometimes, right? And do you see how all of these have pi's in them, right? Along the x-axis, and that's why I'm not using this new version that we learned today. That's going to be good for applications when we get to applications that have no pi's along the x-axis. I'm not using this one for these ones. We'll see that there's an example like that in the homework. Okay, so for this one, how do I, if I can somehow write A, B, C, and D, I'm done, right? Well, how do I do that? I think the first thing is to start out with identifying where the high, middle, and low are. Especially the middle will help us. The middle, right there, y equals 2, is one of these ones. It's the axis, right? This is 2. And then how do I keep going from there? Well, probably I can see what the amplitude is, right? The amplitude is at the height of one bump. A is 1, 2, 3 here. Right? And I can see that straight from the graph. As we'll see soon when we get to applications, maybe we would want to do an calculation for this, but I can see it straight from the graph. No worries. So A and C, easy peasy. Now, for the period, I want to look for, when the graph starts repeating. Well, where is one period of this graph? Where does it start repeating? Well, it starts here, and then it's going to start, ends here and starts repeating there. So this distance is the period, right? That's the period. And what distance is that? Well, it's 2 pi, right? So the period, if the period is 2 pi, remember B is just the value that we divide into the, well, it's 1. B is 1. But there hasn't been a stretch or a squish. B is just 1, and it just is. What phase shift? Well, notice if I picked a cosine function, there'd be a phase shift of D equals pi over 2 to the right, because a cosine starts at its maximum. But I'm going to pick a sine, because a sine starts at its vertical displacement or at its axis, and then I can say it has a phase shift of 0. Putting this all together, a sine function would be, get this color correct here, here we go, y equals 3 sine and 1, so I don't have to write in a b at all, then x minus 0, no phase shift, and plus 2. Done. Notice I could write a cos function, and I said a cos function would have a phase shift of right pi over 2, right pi over 2. So I could have a cos function. And this is where things get a bit strange, because I could have, if I wanted to, I could have had it go left this amount for a cos function. Or notice that I could have had it a sine function that's been moved right this way and then flipped down. I could have thought of that as the starting spot. So how many possibilities are there for this? Well, there's a few, an infinite number of possibilities. Okay, so there's those two, and I'm going to skip a couple, and I'm going to go right to the end one, and I'll go back later. I don't know, can I move this around? Yeah, I can. I'm going to do this one here, and then let you try this one, and then I'll write the answers on only. I'll explain and go through this one fairly slowly, and then we'll call her, well, I'll almost call it a day. So again, what was this sort of technique? Identify high, low, and middle. Sometimes it's hard to identify the middle, but it's halfway between the high and low, right? Halfway between the high and low is the middle. And it looks like I got y equals 2 again here. Great. So if I'm thinking about A equals, B equals, C equals, and D equals, I've got my C equals already. It's 2. I'm moving up 2. And again, I'm looking to fill in all these blanks. Then the amplitude is 1, 2, 3 again, I guess. 3 is the amplitude. That's 3. A equals 3. The period. Where's one period? Well, notice that even though it goes upside down, one sort of cycle is in here, right there. 1, 2, 3, 4 ticks. 4 ticks. It's kind of hard to even see how much that is, but I could think of it. Well, pi over 6, 2 pi over 6 is pi over 3, 3 pi over 6 is pi over 2. This is 4 pi over 6, 4 ticks, which is 2 pi over 3. And again, look at that. When I think of the b value as whatever goes into 2 pi, b is 3 here. Another way to think of this, by the way, and I've kind of made a mess of this, but I'll do this and then erase it soon enough, is I could think of how many copies of the graph can I fit in 2 pi? Well, notice this graph doesn't even go to 2 pi, but there's 1 pi, and there's another pi. So in 2 pi, how many copies can I get in? Well, there's 1. Oops, kind of ugly, like I said. There's 2. There's 3. 3 copies of the sine function. So then, again, b equals 3. You could think of it that way, and some people like it that way. I don't know. Okay, get rid of that blue stuff. All right, what's the last one? Phase shift. And again, the phase shift all depends on, are we going to try and think of this as a sine graph or a cos graph? And that's up to you if you're not asked. I might be tempted to say this is a cos graph. You know why? Cos graph. Because I can see the starting spot for a normal cos graph is just that way, 1 square pi over 6. So I could, this is left pi over 6. So then it's, the d is negative pi over 6. And then I can fill it in. B is 3. Are there more possibilities? Yes. And in fact, some people might have, and I think this is actually maybe easier, this next solution I'm going to give us, is that some people might have said, well, it's already started at the average. Why don't you pick a sine function and just flip it? Why don't you write this one as y equals negative 3 sine 3x, no phase shift then, because it, I haven't moved it left or right, and then plus 2. And notice these are both completely fine. All right, what I'm going to do is get you to pause the video. You try these other two. I'm just going to pause, write the answers on there, and then we'll go into the last little bit of business. So pause the video now and give those a go, please. All right, I hope you tried those. Here's my solution. This is for a sine graph. If you had a cos graph, you'd have a phase shift in there as well. The period calculation is maybe the hardest, and remember, we just look for how many ticks it takes to start repeating itself and then figure out what b is, right? Well, the period 2 pi over 6 is 4 ticks. 4 pi over 6 is a tick is pi over 6, and that's 2 pi over 3. That's how long it starts to take repeating itself, and then there's the function. This one down here, again, the period, a little harder to see, but it's 6 ticks. 6 ticks is 6 pi over 6, or just pi, and then a little period calculation gives me that b is 2, the amplitude is 1, the phase shift is a couple of ticks. For a sine graph, if you wrote a cos graph, it's a little more difficult because it actually falls, the maximum, the starting spot, falls right in between 2 ticks, and it's not much fun, but you probably can do it there too. And I'll let you argue about that in class. For homework, there's a couple to graph, and if you ask or remind me nicely, I will post my solutions on Facebook, or you can put them into a graphing calculator. This is the idea of having numbers along the x-axis instead of pi's, and then there are some from the homework that are on writing equations, and here's an example here. Notice this one, since it doesn't have pi's along the bottom, I would think of it as this other version, this version, right? Pi's in the equation, not in the graph. This is an actual application, so I'm going to use this slightly different version. Well, same deal. Big B is the period, though. Amplitude is just 1. Big B, the period, how long does it take to repeat itself? 0.5. C is how much it's been moved up or down, 0. And D, it hasn't been moved up left or right at all for a cos function. And notice I picked cos because it started at its maximum. If it started, if I wanted a sine graph, I could have a phase shift of a bunch there, but Why not make life easy on myself here? A mention here, A is 1, of something goofy the book does. And you'll have to be aware of this. D is 0, so there's no brackets. And C is 0. They'll actually calculate this and have so many pi's. So they'd go and jam it into your calculator. 2 divided by 0.5 is 4. So they'd actually have this as cos of 4 pi over x. I don't like that, actually, because the advantage of having these application ones is that the period jumps out at you, right? In this one, it's a calculation you have to do. This is nice, and I like this one better. Oops, turn that frown upside down. Oh, there it is. Now he's happy. I'd rather this than this because I can't see the period. All right, good luck with your homework. Gsf 3.